Okay, guys, hello. How you doing today? We're going to continue a little bit with trig. We're going to do 3 more sections, guys, okay? I just want to make sure that you go into next year knowing exactly what to do. I'm showing you the basics. After these basics, then you can add on to it, and trig gets a little bit harder after that. But I promise you, if you know your basics, life is a lot easier for you. Okay, first off, we've been over this triangle a lot. I'm just going to go over it again just because I'm annoying. When I have a triangle, a right triangle, okay, please remember that this triangle, I labeled the sides with respect to angle A or the theta. So I labeled these sides with respect to that angle A. Okay, they all change if I go to the respect of angle C. What's the only one that never changes? Hypotenuse, very good. That's always across the 90. Excellent, guys. Adjacent is next to the theta, or the angle in question, and opposite is across from the theta, or the angle in question. Remember that theta or alpha are just Greek letters used to represent angles. You can also have any multitude of Greek letters, but those two are pretty popular. Okay, this is, again, a little bit of review, but I wanted to make sure that you guys understood this because today we're really going to use this concept, all right? When you have an angle, every angle is going to have an initial side, and the initial side is the x-axis, okay? That's this red guy right here. That's the initial side. And the way that an angle works is it's literally kind of like the hands of a clock, except it's going counterclockwise. You know how the hands of the clock just go round and round and round and round, right? Well, they're making different degrees every time they move. And when you have a counterclockwise movement, you have a positive angle. Okay? Positive angle. So basically what's happening, this guy is just going around and around and around and around. Around and around and around and around. You with me, guys? Okay? And where it ends, that's called the terminal side. You with me, guys? And remember, all of this is happening within a big circle. You guys with me here? Okay. A negative angle. Gentlemen, a negative angle, luckily you're still going to have an initial side that starts at the same place, my brothers. And you're still going to have a movement, but this time you're going to have a counterclockwise movement. I mean, a clockwise movement. And a clockwise movement gives you a positive angle. I mean, a negative angle. So a negative angle goes this way. Clockwise. 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 Okay? That's a negative angle. Where it stops, that's called the terminal side. Hence, it terminates. It ends. Terminal. Okay, that's where it ends. You with me, guys? That's why, by the way, in the airports, there's terminals, because terminals is where the plane lands, where it stops. That's the plane's terminal. Mickey Mouse so far, right? All right. Let me show you guys how to start drawing triangles. Angles. When we draw angles, guys, you have to remember that you're starting at an initial side. And the initial side will be the x-axis right here. Okay? I'm going to do these color coordinates so you can see exactly what's happening. Please follow me. You guys do remember the quadrantal angles that this is 90, that's 180, 270, and 0 or 360. Awesome. Then this is going to be very simple. When I want to graph the angle 225, well, I start here on my initial side, and I'm going to go 90, 180, and then 45. That's my angle. So this whole entire angle is 225. I'm sorry? Yes, it matters where you start. You always start here at the initial side, sir. On the x-axis. Oh, you mean like where I started this thing? Like this loop? No, the loop doesn't matter. I'm going to end at the same spot. Yes, sir, my brother. That's an estimate right there, right? But how would we make it exact? That's a great question, son. Let's say you had someone who's a stickler. Then do this. Okay, you have your, let me do it in green, sorry. Okay, you have your initial side. You went up 90, 180, anyone can see that. And then just put a little 45 here. A 45. What's 180 plus 45, guys? There you go. That way you show the reader, hey, look, dude, I went 90 and 90, that's 180 plus 45. That whole angle is 225. Yes, sir. Yeah, but we're not going to complicate things with slopes because it will have a slope of 1. You're absolutely right. I love your thinking when it's a unit circle. But it won't always be a unit circle. It could be larger. Good thinking. And don't worry about making the equation of the terminal side of the angle. Don't worry about that. Just label the missing piece, and that way we're good. Does that make sense? All right. Let's go to blue, and let's do 495. So that's my initial side. I got one full circle is 360, right? So 360 plus 90 is 450. Okay, sorry about that interruption, guys. We'll just go backwards real quick. Okay, everyone understands that I went one full circle here, right? Okay, what's 360 plus 90? 450. Plus how much more to get to 495? Okay, so I can put a little 45 here if you wanted to, and you would know. Is that a super accurate angle? No. But if you label that 45, does it make it accurate to the reader? Yes. Does that make sense, my brothers? Okay, may I erase it? I'm going to now do negative 210. Don't be afraid of the negatives. You're just going clockwise. So I'm going to go negative 90, negative 180. And how much do I have to go to get to negative 210? Another 30. And that's my angle. That's my angle right there. Negative 210. Because I went 90, 180, and another 30. That's negative 210. I know this seems simplistic, and it is. And I promise you this skill is going to really benefit you later on. Like tomorrow. Yes, sir, my brother. Okay. What my boy is saying is this. Mr. Morrow, do you have to do the little guiding thing? I'm not 4 years old. No, you don't. If you want to know, okay, I have to cross this quadrant, that's 90, another 90, okay, and I need 30 here, I will accept that. But here's the only problem with that. How will I know if it's a negative or positive if you do that? Nah. Well, okay, because you put the 30 in the bottom, I guess. But this way you know that you went negative. Okay. Oh, I'm sorry. What were you asking then? I'm so sorry. Okay, his question was 360. Can I go 360 minus 210, and that gives me a positive 150, which is 90 plus 60? Yes. But if you draw it like this with this arrow here, then you're talking about a positive 150, when what I wanted to show was a negative 210. So you're right, but you'd be wrong. Sir. Shh. We're going to talk about that right now, but it's not useless at all. We're going to talk about that right now. Thank you so much. You guys with me? These are great questions. Thank you. Okay, now, this is going to relate right to what you said, my brother. Coterminal angles. Coterminal. Let's think about that. What does co mean? Two, right? Together, correct? And we had already decided that just terminal means what? It ends. So put those two words together. What do you think this is talking about? It's where two angles end at the same spot. When two angles are coterminal or three angles are coterminal, coterminal just means, hey, look, even though these are different size angles, they both end, they both terminate at the same side. They both have the same terminal side. What does this mean? Well, it's angles which end in the same terminal side. They have the same trigonometric value. So if they end at the same side, they're going to have the same value, which is what we're going to talk about tomorrow. We're going to take baby steps with this. I want to make sure you got this perfectly. Okay? So if they end at the same spot, at the same side, same terminal side, they're going to have the same exact value. I promise you. I swear. Always. There's no exception to that. How do you find coterminal angles? Coterminal angles are found by adding or subtracting multiples of 360. Let's see what this crazy man's talking about. Let's say I have an angle. Angle A is 60 degrees. Okay? 60 degrees, I'm going to go up here 60, right? And that's my angle, correct? You with me, guys? Now, if I want to find a coterminal angle to this, simply add one full rotation. Add 360. What am I going to be left with? 420. Now I'll prove that this works. You have 360. What's 360 plus 60? Bam. Did it end at the same terminal side, guys? Yeah. So it will have the same value. And I'll show you why tomorrow. Hint, hint. It's because they have the same reference angle. And we'll talk about reference angles in a second. What if I had, may I erase that? What if I had a huge angle, like 700 degrees? All right? Do you really want to go 360? And then, no, not 360 again. That'd be 720. So 360 and 180 is a 540, right? 540 and 90 is 630, right? And then 70, right? So you'd put a little 70 there. Do you really want to graph that? No. So how would I make this easier? Thank you. Subtract or add multiples of 360. That's going to be 240, correct? Well, check it out, guys. Instead of having to do two circles, can I just go, wait, that's wrong. It's 340. Maybe I should learn how to add. So I went 180, 270, and another 70. Hey, wait a second. Don't I end at the same spot? That's what a coterminal means. Coterminals are angles that end at the same spot. So my brother, why is it, you said, what's the point of having any angle over 360? Whenever I have an angle over 360, that just means that I had several revolutions. When you guys get into this really heavy, or if you ever become an engineer, you guys understand that motors have pistons, correct? Right? Okay. And the pistons go up and down, up and down. But there's a circular motion that is spinning that. So have you ever seen in the odometer of your car revolutions per minute? I'm not trying to be sarcastic. And they're in the thousands. So what happens is, I can't even come close to it, but they're just measuring how many times your engine block goes around. Because every time that your engine block goes around, these guys go up or down. And what happens here is down here where they're going down, there's a pool of gas. And as the pistons go up and down, they come down on top of the gas with such an enormous amount of pressure that they combust, hence the combustible engine. It literally blows up. You're literally having a mini explosion, a contained mini explosion in your engine. That explosion is what gives you energy and you go forward. That's, very basic. I'm not an engineer, but that's very basically what's happening. Well, these revolutions per minute, think about it. They're measuring. And that's not even anything. You have Sometimes 3,000 revolutions per minute. That means that you're having 3,000 spins in 1 minute. Does that make sense, guys? Okay, so this is why coterminals are so important. If I'm dealing with an engineer that's building an engine, and I tell him, look, I want this engine to have, whatever, 2,500 revolutions per minute. Am I going to work with 2,500 as the angle? Or am I going to start subtracting 360s until I get to a nice reasonable angle? Because let's say that this angle ends right here. And let's say that little extra piece was, let's just say 50. Wouldn't that be the same thing as just drawing a 50-degree angle? As far as value goes, the value of all of these circles is going to be the same thing as the value of an angle of 50 degrees. Does that make sense, guys? Promise? Okay. May I continue? Thank you, gentlemen. Okay, last thing. Find one angle with a positive and one angle with a negative coterminal with each angle. Okay, so I want a positive coterminal. So, add 360. So my positive coterminal would be 640 degrees. Now, how would I find a negative coterminal? Subtract 360. Thank you, gentlemen. So it'd be negative 120. So guess what, guys? 280, 640, and negative 120, I swear to you, have the same value. If you were to put the sine of 280, that will equal the sine of 640, and that will equal the sine of negative 120. I promise you. The sine, or the cosine, or the tangent, or the cosecant, or the secant, or the cotangent. Okay, for B, 580. How can I find a positive one? You could add 360, but what would be an easier route? Subtract 360 because I'm still in the positive realm. Right? Now, how would I get a negative one? Subtract by 720. Excellent. Thank you, gentlemen. So 720, and actually this was wrong. That's wrong. And I cannot believe that nobody caught this. This is wrong, guys. Right there. That's wrong. I'm going to show you right now. We all made the same mistake. So all of us have to learn how to pay attention. Guys, when you subtract, you subtract as normal. So that would be negative 80. We both failed on that one. Sorry. No excuse. Okay, we both failed here. When you subtract, when you're adding signs that are opposite, you subtract as normal. When you subtract as normal, it's the large number minus the small number, and then you keep the sign of the largest absolute value. So here, this would be negative 140. Does that make sense, guys? So negative 140, 220, and 580 all have the same value. Okay, what's a positive and a negative coterminal for 120? You add 360, so if you add 360, you're going to get 480. And if you subtract 360, you're going to get negative 240. So negative 240, 480, and 120 all have the same value. Sir? It is. But I did it in my head. 360 minus 120 is 240. There's more negatives than positives, so it stays negative. Thank you, Bubble. What about negative 470? What's a positive and a negative there? Add 360 to get the negative. Very good. So that's going to be negative 110. And then I would add 720 to the negative 470. And that's going to 250. Positive. So 250, negative 110, and negative 470 all end at the same spot. They all have the same value. You with me? Okay, now, remember the unit circle, guys? All right. We're going to give you the real unit circle now. Okay, let me explain first what my boy really recognized. All students take calculus. Let me explain this. Tomorrow, we're going to be finding the sine of 150, for example, without a calculator. We're going to be finding the sine of 300 without a calculator, or the cotangent of 140 without a calculator. Okay? Actually, not 140. 225 without a calculator. How are we going to be able to do this? Because we're going to use reference angles. What on earth are reference angles? Well, guys, the reference angles come from the triangles that I taught you. They're the 30, the 60, the 45, and then the 0, 360. These are the quadrantals, 90, 180, and 270. Now, I don't expect you to memorize this today, but eventually you will memorize this. Now, whenever you have an angle land in the first quadrant, all of the trigonometric functions are positive in the first quadrant. Students, whenever an angle lands in the second quadrant, only the sine and cosecant will be positive. Hence the S, right? So only the sine and cosecant. Are you guys going to memorize this, or are you going to write it down? Oh, okay, because I think you're going to memorize it. So students stand for sine and cosecant. T, take. Tangent and cotangent are positive only in the third quadrant. Everything else is negative. And calculus, C, only the cosine and the secant are positive there. So first quadrant, everything's positive. Second quadrant, only the sine and cosecant are positive. Third quadrant, only tangent and cotangent are positive. Last quadrant, only cosine or secant are positive. Everything else is negative when it lands there, okay? You guys with me so far? Okay, now, I'm going to erase this, okay? Okay? Thank you. Now, let's look at some stuff. Let's look at my quadrantal angles. Remember that I told you that the x value is the cosine and the y value is the sine, correct? So your cosine is 1 at 0 and your sine is 0. You can find everything else there. Remember that tangent equals sine over cosine. Once you have the sine, cosine, and tangent, you can find all the reciprocals. Please remember at 90, cosine is 0, sine is 1. Remember that at 180, cosine is negative 1, and sine is 0. And please remember that at 270, cosine is 0, and sine is 1, is negative 1. Now, do you have to memorize that, or can you just draw the little circle like I taught you? You could draw a little circle. Now, let's look at all of this stuff here, guys. These here are already the sines and cosines derived from the 30, 45, and 60 triangles. Let me prove it. If I drop this down, this is a 30. Across the 30 is a 1. Radical 3 across the 60 and a 2. Guys, what's the cosine of 30? Adjacent over hypotenuse. Ain't that square root of 3 over 2? What's the sine of 30? Opposite over adjacent. So boom, 1/2. You can memorize this whole entire thing, or you can really just learn how to work with the 30, 45, 60, and 90 triangles. Let's go to the next one. Let's go over here. Let's drop it down this way. This whole thing here this time is going to be the 45. And remember that with the 45, you've got a 1, 1, and a square root of 2. Okay. Okay, Thank you. I'm very proud of you. He just said, whoa, hold on, Miss Morrow. The radius you told us clearly in a unit circle was 1. What on earth are you doing to us? Remember that I told you guys that I use this triangle for calculations. But what's really happening here? I'll show you. Thank you, by the way. You're very much thinking, and I'm very much proud of you. This is 45, right? I know that this is 1. All right, you with me? That's 1. Okay, but in a 45-45 triangle, isn't this guy equal to this guy? Okay, and isn't the hypotenuse of a 45-45 triangle square root of 2 times the side? So 1 equals s times the square root of 2. Divide by square root of 2. So I'm going to have square root of 2 over 2. So this is square root of 2 over 2, and this is square root of 2 over 2. You with me here, guys? Promise? You guys with me so far? Okay. Now, that's the real unit circle, but do you like working with all of those numbers? No, right? No, right? So multiply everything by a square root of 2. What are you going to be left with? Square root of 2 here, a 1 here, and a 1 there. So yes, my brother, I had to go through this because you're right. I don't want you to think now, oh, Morrow just made up his own damn circle. No. It is a 1. But when you do all the calculations, you get to this at the end. Are you with me, Bubble? Yeah. Thank you, sir. So that's why you got the sine of square root of 2 over 2 and the cosine of square root of 2 over 2. You guys with me? Okay. I'm going to erase all of this for a second, clean it up a little bit, okay? Is that cool? Excuse me. Okay. Now, if I go this guy here, this is coming from the 60. And the 60, even though, yes, this hypotenuse is really a 1, when we're talking about a 60, though, we find out calculations by doing square root of 3, opposite the 60, 1 opposite the 30, and 2 opposite the hypotenuse. Those are not the figures for a unit circle, but those are the figures that we're going to use to find these values. What's the sine of 60? Opposite over hypotenuse, radical 3 over 2. What's the cosine of 60? Adjacent over hypotenuse, 1/2. So when you have this memorized, guys, let me show you now how badass this is. Ready? I'm going to blow you away. My 30 is square root of 3 over 2, comma 1/2 in the first quadrant, right? But in the second quadrant, why is this square root of 3 over 2 negative but not the 1/2? Because the sign here is positive. Look, the sign for all of these will be positive. So are all of these equal to all of these? Yes, in a sense. They're all going to have the same reference angles. This 30, that's called a reference angle. If I made it the 45, that's the reference angle. We're going to talk about how to get this tomorrow, but I'm just giving you a little heads up. This guy here, that whole angle, that's 60. That's the reference angle. Over here, that's still a 30. Same reference angle, different signs. It's positive or negative now. Right here, this reference angle's 45. Same values. It's just now one of them's negative. This whole angle over here, the whole thing is 60. Reference angle. The reference angles are always going to have the same values. And that's where we get this whole entire circle from. My 30, 60, 90, my 45, 45, 90. And you get the different signs because of all students take calculus. Now again, I don't want you to go home and stress. However, I want you to analyze this. You should for sure know how to set this up, these guys. And for sure by now, for tomorrow to be successful, you got to know that this 30-60 triangle is like this. Excuse me. And the 45-45 is like this. If you know the 30-60-90, the 45-45-90, and the quadrantal angles, Tomorrow will be a breeze. If you don't know them, it's going to be tough. Now, for the ambitious student, you want to memorize these? Awesome. God bless you. Because then you just memorize the cosine and sine of 30. The second one's the cosine and sine of 45. The third one's the cosine and sine of 60. How does that help you? If you know the cosine and the sine, then you know the tangent. If you know the sine, the cosine, the tangent, you know all of them. That makes sense, guys? God bless you. Thank you very much. Homework is valid. Have a great day. Thank you.